Hi guys, so I'm going to do some sort of non-traditional notes for 4.2. I do have a couple things to mention in the beginning, but then what I'm going to do for the notes is just go over some example problems in the homework. And then your homework is to do like pretty much the evens. Or sorry, on the notes I'm going to do the evens, and then your homework is to do the odds. So you can use this as a reference when you're doing the homework. Okay, so 4.2 relies on a couple of formulas that we need to know from geometry. So that was a long time ago, but it's now starting to be very useful in this unit because we need to know about 30, 60, 90 right triangles and 45, 45, 90 triangles and their properties. So rather than do like a whole unit on those properties and why the formulas are the way they are, I decided I'm just going to tell you what you need to know for this homework. So what you need to know is that in a 30, 60, 90 right triangle, so let's say that this right triangle is within a circle. So picture, I don't want to draw it, but picture this, there being a circle over here. And this point up here is like this is the center of that circle, and this is the outer point on that circle. So we basically have just kind of removed this right triangle from that circle. And we're going to go with the fact that the radius of the circle is 1. And if that's true, then the side opposite, we're going to call it the short leg because this is opposite the 30-degree angle, which is smaller than 60. The side opposite the short angle is always half of whatever the hypotenuse is. So half of 1 would be 1/2. And then the side that's opposite the 60-degree angle is always √3 times the short leg. Well, the short leg is 1/2, so it's kind of like 1/2 √3, but we're going to rewrite this as √3 over 2. Same thing. Okay, so we need to know this to do the homework. If you want to write that at the top of your homework as a reference, that would be good. Then, if you happen to end up with a 45-45 degree or 45-45, 90 right triangle, then we know that the two legs are congruent. And again, so this would be like the radius from our circle. The radius is 1. If that is the case, this one's a little trickier, but the legs are always going to be congruent because it's an isosceles right triangle. And the hypotenuse is always going to be √2 times the short leg, or the legs. But since the hypotenuse in this one is 1, what we do is we set this equal to x √2, and we solve for what x. So these are considered the legs. Like I said, I'm not going to really go into explaining how the formula works, but it would just be helpful to use this as a reference that if the hypotenuse is 1, it just means that the legs would have been √2 over 2 and √2 over 2. We can verify this in multiple ways, do Pythagorean theorem, but we're getting toward the end of the year, so I'm going to kind of go a little quickly on this part. All right, so we're going to use our knowledge from the properties of these two types of right triangles to answer the questions below. For number 10, and there is a lot of geometry, basic trig from geometry that we need to know, but I'm looking at the directions for number 10. It says, determine the exact values, I'm right here, determine the exact values of the 6 trigonometric functions of the angle theta. Okay, so we're given that the coordinates of at that point are 12/13 and 5/13, and we need to figure out what the coordinates are for each it says of the 6 trig functions. So what are those 6? We know the basic one, so let's go sine. Sine is the y coordinate, so sine of theta is going to be 5 over 13. Got that? Cosine of theta is the x coordinate of that point on the circle, which is 12 over 13, but then it gets a little harder. So now we're going to do tangent of theta. Well, tangent is, if you watch the Khan video when he did the SOHCAHTOA, tangent is just opposite over adjacent. So the other way to think of that is it's sine over cosine. And then I'm going to draw in on the picture here. I'm going to just draw that in. So in other words, this, if that's saying 12 over 13, that must have meant that this was 12 and the hypotenuse was 13. If sine is 5 over 13, it just must have meant that that side would have been the 5 because that's opposite over hypotenuse. So therefore tangent is opposite over adjacent. So tangent would be 5 over 12. Okay, so that's 3 out of the 6 trig functions. The other 3 functions are the inverse of what you see here. So on your calculator you have buttons for those. And the first one, we'll just do it for sine. The inverse of sine is cosecant. So we write that as, I think I'll do it down here. So cosecant of theta. It's basically whatever sine is, but it's 1 over that. So it's 1 over 5/13. Well, 1 divided by 5/13 is the same thing as just flipping it. So it's like saying 1 divided by 5 over 13, but really that's the same thing as saying 1 times 13 over 5 because you multiply by the reciprocal. So therefore it's just taking the reciprocal of that ratio. So cosecant of theta is going to be 13 over 5. I'll circle those ones. So again, I'm just doing examples so that you can do the homework. And then the inverse cosine is going to be the secant of the angle. So secant of theta, it's just the reciprocal, so we're just going to call that 13 over 12. I don't need to do the math like I did here because I think you guys get it that cosecant is reciprocal of sine. Secant is the flipping of cosine, and then tangent, the flip of that one is cotangent of theta. So if I do the reciprocal of 5/12, it would be 12/5. Okay, so there you go. You've answered the question for determining the values of those trig functions at that point. Okay, then the next concept in the book, it's from number 14. It says, oh, sorry about the blurriness. Find the point x, y on the unit circle that corresponds to the real number t. So you can see t is equal to pi over 3, and we need to figure out what the coordinates are at that point. Okay, so I recommend drawing a picture just to kind of give yourself a model. So it said t is equal to pi over 3. So I'm going to figure out where pi over 3 is. We did this in 4.1. So locating pi over 3, I like to draw in my half circle, so because I know that this spot over here is going to be pi. And I'm going to divide that upper half into 3 parts because it's the denominator is 3. So 3 equal parts. Therefore, I'm going to say, okay, well, pi over 3 is going to end up somewhere right about there. And then what they want us to do is figure out the coordinates. Well, we know that the coordinates at this point x and y, it's the same thing as the cosine of theta, the angle, and sine of the angle. Those are your x and y points. So I'm going to do a little drop down here, and I've got myself a right triangle. There's my altitude, and pi over 3, if we want to convert that into degrees, we learned that you can just multiply it by 180 over pi. Let's do that, and we'll figure out our degrees. So those are going to cancel. And so the 3 is going to go into the 18. So that's going to go in 6 times. So basically, we know that this is a 60-degree angle right there, 60. So I'm going to draw a larger version of that right triangle. Jenna is climbing on my back while I'm doing these notes in case my pen goes all over the place. You can say hi, Jenna. All right, so, oh, I don't like how it's a little blurry. I gotta make that better. Sorry, everybody. Okay, so if that's my 60-degree angle, I got that because the radians were pi over 3. Then I need to go back to my little formula up here. So the radius is 1. The side opposite the 60 is going to be root 3 over 2. So let me go back to do that. This must be root 3. I don't know why I wrote. It's right as pi. Okay, that's really root 3 over 2. This would be the 30-degree angle by default. So that means from our notes up here, that is going to be 1/2. Janet, don't hold on to it. So this one's 1/2. That's a 1. And they want the coordinates. So all I need to do is figure out what would the cosine be. The cosine of angle 60 degrees is adjacent over hypotenuse. So that's going to be 1/2 divided by 1. 1/2 divided by 1, which anything divided by 1 is itself, comma, and then we'll do the sine. So the sine is going to be opposite over hypotenuse, so that'd be root 3 over 2 divided by 1. Okay, well, we already know. It's just going to be the same as 1/2, comma, root 3 over 2. That is the answer we're looking for. Those are the coordinates at that point when you are at pi over 3 radians on the circle. All right, next one. So that was 14. Actually, you know what? I'm going to stop the video, and then on the next video, I'm just going to answer these 2 more questions, and then the notes will be done.